Okay, this is your tabular problem. It's giving you the velocity of a plane. Okay, it does tell you it is differentiable, so you can assume it's continuous. So part A is we want a midpoint Riemann sum. I'm going to use 4 rectangles, equal length, and we're going to go from 0 to 40. Okay, so midpoint, in order to use 4 rectangles, here's the width of my first rectangle. So the width of my first rectangle, I'll do part A up here, is going to be 10. And in order to use the midpoint, I have to use the number in the middle. The number in the middle, the y value is 9.2. Plus, the next rectangle is going to go from here to here. Again, width is 10. The midpoint there is 7. And keep going. The next width is also 10, and I believe they told you it's going to be equal length. 2.4. The last rectangle, again 10. The midpoint there is 4.3. And if you punch this all out on your calculator, you should get 229, and this would be miles. Okay, because the units are minutes, miles per minute. All the minutes drop out, so you're left with total miles. Okay, so they want to see the commutations. There's your answer, and then it also asks you to, using the correct units, explain the meaning. Okay, what do we know when we integrate the velocity? Okay, it says positive velocity, so all the points are above the x-axis. So I know the meaning of this integral is total distance traveled. Okay, in miles, using correct units, from t equals 0 to 40 minutes. Okay, make sure you have units. Always explain these bounds on this integral. Okay, part B. What is the smallest number of instances at which the acceleration could equal 0? Okay, so they want to know, when is the acceleration equal to 0? The only graph you have is the velocity, so you're looking for where actually the slope of this graph equal to 0. So you know that this graph is differentiable, which means the function is continuous. So even though you only have selected points, you know from here to here it's got to make a continuous graph. So let's just look at the points. It starts at 7, then it goes up to 9.2, then it goes up to 9.5, then it's going to come down to 7. Now I don't know if this is what the graph looks like. In between here, it could go up and down. We're not sure, but I know it hits 9.5 somehow, and it's going to come back down to 7 at some point. So somewhere in here, it's got to go up and come back down, so you have to hit a horizontal tangent. So I'm going to say somewhere between 0 and 15 it's got to happen. I'm not sure exactly where. Okay, now let's keep going. It goes down to 4.5, it goes down to 2.4, it goes down to 2.4, and then it goes back up to 4.3. So again, same thing. The numbers are going to go back up, so I also know somewhere between 25 and 30 it's going to happen. So there are exactly 2 instances. That's the only, and then from here it goes up and goes up. Now it doesn't mean that it could go to 4.3 and then go to 10 and come back down, but we don't know what happens in between. So we know for 2 instances for sure at which the acceleration or the slope of this velocity graph is equal to 0. That's all I can say. Now it says justify your answer. Okay, what is this? This is your mean value theorem, okay, because the function is differentiable, so is differentiable and continuous. So there has to be 2 places where the slope is equal to 0. Okay, so this is your mean value theorem right here. Okay, part C. Based on the values, okay, they give you a function for the velocity. What is the acceleration? Oh, just use your calculator. They're telling you f of t is velocity, so to get to acceleration, you just find f prime of t. Just use your calculator. I get negative 0.40769 miles per minute squared. Correct units. And lastly, part D. What is the average velocity? I see that word average. I'm thinking 1 over b minus a to b of whatever that function is. What are they asking you to find the average of? The velocity. They give me the interval 1 to 40, 0 to 40. What do they want you to find the velocity of? The velocity function, which they gave you, was f of t. That's your setup. Type this into your calculator. Miles per minute are the units on velocity.